Alright, so here is your study guide for Test 5. The first section is just to rank the following from lowest boiling point to highest boiling point. So really look and see what IMFs they have, and then we'll take it from there. So starting off, we know that we're not going to have anything that's just London, because they're all different and there's no way for them to be symmetrical because there's just two things, so that's easy. So they're all going to be at least dipole. Now, if you look at this HF, remember, and you know, if you want, you could draw these out, though it's very pointless. They look exactly the same. Remember, hydrogen bonding happens between a hydrogen and a nitrogen, oxygen, or fluorine. So this one has hydrogen bonding. The rest of these, just their strongest force is dipole. So you know, if we're thinking about lowest to highest, right, you know, and if we just make these 4 spots, that the highest is going to be HF, because it has hydrogen bonding, so it's going to be the highest. Again, for us, for this class, for our purposes. So now the next thing is just how far apart are these? The further apart they are, the stronger the dipole, the higher the boiling point. So all you do is you look at a periodic table, which you can't really see, but there's H, and then we're looking at Cl, Br, and I. So if you look at this, the I is furthest away, the B is in the middle, and the Cl is closest. So what that means is the HCl will be the weakest because H and Cl are closer together. The HBr will be next, and the HI will be strongest because they're further away, and then obviously the HF is the strongest because it has hydrogen bonding. Alright, so these are all diatoms, right? They're O2, H2, N2, Cl2, so you know they're all London. So how do we determine what's strongest with London? Size, right? The biggest one has the highest boiling point, the smallest one has the lowest boiling point. So you just literally get their masses on the periodic table, right? So this is 2 grams, this is 28 grams, this is 32 grams, and Cl2 is 71 grams. So you just put them, that says 71, I promise. So you just put them in that order. The one that's 2, which is hydrogen. That's why we use pencils, right? Hydrogen, the next would be the 28, which is the nitrogen, then the 32, which is the oxygen, and then the 71, which is the chlorine. Same exact thing for this. Hydrocarbons, like this, are always only London, like we've talked about in class, so it's just smallest to biggest. So CH4 is the weakest, which is methane. We've seen that in class. That's the gas that comes out of your stove or out of the pipes in the chem lab. It's a gas. It has very low intermolecular forces, so it has the lowest boiling point. And then just do it in order of size. C2H6, C4H10, and C5H12. Okay, now things start getting a little bit trickier. And that's why I left a little more room here. We have to start kind of figuring these out. Now, this says NH4. On your version, it won't be a typo. I fixed the typo, but it should say NH4. So you kind of have to draw these out to figure out their IMFs. So O2 we know is just going to be London. That one's easy because we just did it up here because there's only one type of atom. It makes life easy. The rest of these let's draw out. So CO2, if you draw out the Lewis structure for CO2, you'll get something that looks like this. There is another way to draw it, but it doesn't matter. Either way, it's nonpolar. There's no dots in the middle. It's nonpolar. So this is also only London. Now let's check out NH4. NH4, again, if you draw out the Lewis structure, will look like this. No dots, all symmetrical, also London. And then the CH3OH, on a test I would probably give you the actual structure of it. I wouldn't expect you to be able to necessarily draw that. This has dipole and actually hydrogen bonding. So this, we know right off the bat, if we're going to make our 4 spots, we know that that methanol, that CH3OH, is going to have the highest boiling point because it has hydrogen bonding and the rest are only London. So now since the rest are all London, you just go simply based on the mass. So again, if we look up the mass, the carbon dioxide is 44, oxygen is 32, ammonium is what this is called, NH4 is 18. So when it's just the 18, which is the smallest, is NH4, and then the 32, which is O2, and then the 44, which is CO2. All right, let's check out the next page. So this is some stoichiometry. Everybody loves stoichiometry. I know it's your favorite. So given 25 grams of each reactant, meaning each thing on the left, calculate the mass of the bold product. So in some of these, like this, there's only one product, so obviously it's that. But in others where there's multiple products, I bolded the one I want you to find. So definitely the first step is balancing this. So let's do that. 8 sulfur, 1 sulfur. So you need to put an 8 there. Now we have 24 oxygen. So if you put a 12 there, we have 24 oxygen. Yay. All right. So now let's convert these both to moles. We have 25 grams of S8, and we want to turn that to moles. Get on your periodic table. You'll see that S8 weighs 256.5. So you do that math, and you get 0.0975 moles of S8. So we want to convert that now to the product that we're asking about, which in this case there's only one product. So remember, you multiply it by the ratio of the coefficients. There are 8 SO3s for every 1 S8, just based on the coefficients. So if we do that, we will get 0.78 moles of SO3. Alright, now we're going to do the exact same thing with, oh goodness, okay, we're going to do the exact same thing with the O2. 25 grams of the O2 times in the line. Again, periodic table, O2 is 32. So you do that and you get 0.781 moles of the O2. Now we need to convert that to the SO3. There are 8 SO3s for every 12 O2s. Right, this one's a little different because there was a 1 in front of the S8, which is where you get that, but there's a 12 in front of the O2, which is where you get that. So we do that math, and we get 0.52 moles of SO3. So we have enough S8 to make 0.78 moles of SO3. We have enough O2 to make 0.52 moles of SO3. So how many moles of SO3 do we make? The smallest one. Right? So this is garbage to us. We don't even care about that one anymore. So last step is just to take the moles of SO3 and turn it to grams. So 1 mole of SO3, again, you get on that periodic table, and you'll see that it weighs 80. So you will get 41.6 grams of SO3, and that is our final answer. All right, I'll do one more. I'm going to come down here and do C, primarily because balancing is a little tricky, and so I thought I'd do it for you. So the first problem I see here is this O is an odd number, right? It's O3, and we can only multiply even numbers here. So there's no way I'm ever going to get this to be an odd number. So that means I need to make this an even number. Now if you went through and did your guess and check and everything, you would figure it out eventually. But anytime I see this odd number here, where I have an even number here, I'm just going to put a 2 in front of that, because now I have 6, which is even, which I can get to, which works. So I threw that 2 in front of there. Now I have 4 iron, so I need to put a 4 in front of that iron. Now I have 8 sulfur, so I need to put an 8 in front of that sulfur. Now I have 6 oxygen here and 16 oxygen here, right? 6 oxygen here, that's an O, and it looks like 6D, but it's 6O. And I have 16 oxygen here. So I have a total of 22 oxygen. So I want to put an 11 there, so I have 22 oxygen. Alright, now I'm going to do the same thing I did up there. I'm going to turn my 25 grams of FeS2 into moles, get on the periodic table. You'll see that weighs 119.8 and gives you 0.209 moles of FeS2, which we then need to convert to the bold one, which is the Fe2O3. So there are 2 Fe2O3s for every 4 FeS2. So, I mean, we're dividing in half. So that's going to be 104 moles of Fe2O3. Now do the exact same thing with oxygen. 25 grams of oxygen times an 11. 1 mole of oxygen on the periodic table is 32 grams. So that gives us 0.7813 moles of oxygen. Now we're going to do the same thing again, where we're going to multiply it by 8 over, no. Well, I'll either cut this or be lazy about it and not cut this, and it'll be embarrassing, and we can all have a good laugh about it and move on with our lives, okay? We're going to multiply it, right? We want the Fe2O3. I was thinking of the SO2. So there are 2 Fe2O3 for every 11 O2. Again, just the 2 for every 11. So you're going to take that, and this is where the math gets a little tricky, right? Take that number and multiply it by 2, and then divide by 11. And if you do that, you'll get 0.142 moles of your Fe2O3. Again, you have 2 numbers. How do you decide which one to pick? You pick the smaller one. So then our last step is to take that 0.104 moles of Fe2O3 and turn it to grams. If you get on your periodic table, you'll find that Fe2O3 was 159.7. You multiply that out, and you will get 16.6 grams of Fe2O3, and that's your answer. Alright, lastly, we'll skip over here to the last page. Again, I just picked a couple. I'm going to do C and F because I think they're kind of tricky, and they seem like a good one to do. So you're given 118 grams of lithium nitrate in 1,200 milliliters. So first off, you need to turn this to moles, and you need to turn this to liters, and then you divide them. Because remember, molarity is moles per liter. So, 118 grams of lithium nitrate. We're just going to turn this to moles real quick. You get on the old periodic table, and you see that it weighs 68.94, which will give you 1.71 moles. And now you just need to take the moles and divide it by the liters to get molarity. But you have 1,200 milliliters. So remember, you're just going to move the decimal to the left 3 times. 1, 1.23. This is 1.2. So you just go 1.71 divided by 1.2, and you get 1.43 molar solution. Alright, then the other one I want to do is the very last one, is F. So it gives you a V1 and an M1. And it asks for, we're asking for the M2, and we need to kind of think about the V2. So we're obviously using this reaction, or this equation, right here. And we know M1 equals 0.75, and we know V1 equals 1.1. We're trying to find M2, that's the entire question, but V2, we're not given directly, we have to kind of think about it for a second. So think about it like this. You're given 1.1 liters and you add 250 milliliters to it. So that means your new volume is 1.1 plus, and we have to convert that to liters, 0.250. So really, your V2 is 1.350. So now, M1, V1, M2, V2, you just plug it into this equation right here. So M1, 0.75, V1, 1.1, equals M2, what we're trying to solve for, V2, 1.35. Do a little bit of algebra there, and you get your final answer of 0.611, and that's our answer.